Welcome to this crash course on managing network security with pfSense Firewall. According to a recent study conducted by a major cybersecurity firm, less than half the online population understands the term firewalls, or even know if they have one enabled on their PC. Firewalls are even more important in a corporate or work environment. It not only keeps the corporate network safe, but can also optimize traffic routing and provide a whole range of other benefits. If you are connected to the internet, you are a potential target to an array of cyber threats such as hackers, keyloggers, and Trojans that act through the unpatched security holes. This means that if you, like most people, shop and bank online, are vulnerable to identity theft and other malicious attacks. A firewall works as a barrier or a shield between your PC and cyberspace. When you're connected to the internet, you're continually sending and receiving information in small units called packets. The firewall filters these packets to see if they meet certain criteria set by a series of rules. And after that, it blocks or allows the data. This way, hackers cannot get inside and steal information such as bank account numbers and passwords from you. Basic firewalls, such as the one included in your operating systems, only monitors incoming traffic by default. This may give you a false sense of security. Keep in mind, outgoing traffic with your credit card information, bank accounts, and social security number is not protected. A good firewall will monitor traffic in both directions. That is, both your incoming data and your outgoing data, keeping your private information safe. In addition to preventing unauthorized access to your PC, it also makes your PC invisible when you're online, helping prevent attempted intrusions in the first place. Firewalls are one of the most critical parts of a network. It's the first line of defense that your system has against attacks or unwanted visitors. And it makes all the difference in ensuring your data is protected. pfSense is a highly versatile, open source routing and firewall software. With thousands of enterprises using pfSense software, it is rapidly becoming the world's most trusted open source network security solution. pfSense has all of the features you would find in a commercial firewall solution and more. And it's absolutely free. Better yet, you can customize pfSense based on your organization's requirements and create a unique solution that is perfect for you. In this course, you'll learn about pfSense, all of its key features, how you can install and deploy it, as well as the different tasks you can perform. Let's walk through all the key topics you will be covering in this course. You'll begin with an introduction to pfSense, where you will gain an understanding of what pfSense is, its key features and advantages. Next, you'll learn how to configure pfSense as a firewall. Next, you'll learn all about the different key features of pfSense, such as firewall, failover and load balancer, OpenVPN, IPsec, and Squid proxy server. In light of the course overview, what will you be able to do by the end of this crash course? Let's quickly look at the learning outcomes. By the end of this course, you will be able to understand pfSense, its features and benefits, install pfSense in your network, and improve your project and career prospects. At TETRAtutorials.com, we focus on in-demand skills and real-world education. Gaining this practical knowledge and experience with pfSense Firewall and the network security will be very valuable for your career, and it'll be a right step towards improving your work, project, or career prospects. The more in-depth knowledge you have about these IT skills, the more marketable you will be. So what are we waiting for? Let's get started. As much as we love Udemy, we all have some quirks and sometimes we have to live with them. At several points during this course, Udemy may ask you to review this course even if you've watched only a fraction of the entire course. They say you cannot judge a book by its cover, though most people do, and you cannot judge a person after meeting them just for a few minutes. So please don't. Although first impressions may count some of the time, we kindly ask that you wait until we've taken you through the bulk of the course material before you leave a review. That way, you'll have a better basis to rate us from, and future students will have a more accurate idea of how much value we packed into this course. And we love packing in value. It's our favorite thing to pack. Udemy will ask you to rate the course with a rating between 1 star to 5 stars. If you see a dialog pop up asking for you to leave a review, you do have the option to dismiss it until the end of the course. So if you don't feel comfortable leaving a review, then you can just dismiss the dialog until you've had more content to go through. We kind of hope that this is what you choose. We work really hard to bring you some real-world, hands-on education, which has the potential to change your life. We try to make the learning experience as pleasant as possible so that you can get the best learning out of our courses. So obviously, we think this is a 5-star course. Of course, we might be a little bit biased here. Course ratings are one of the most significant factors that Udemy uses to decide which courses to rank higher in search rankings and to promote to other students. So if you feel that this course is great and that other people should be taking it, then your review is going to help the course to rank closer to the top so that we can reach more students and help them to get better results like you. And since we want to make this an excellent learning experience for you, if you feel this course does not deserve a perfect 5 stars, then please post your questions and comments in the discussion area or contact us directly so that we can address your concerns in the most constructive manner. We really want you to be happy. If you leave us less than 5 stars, we'd really appreciate you letting us know where you feel we went wrong, so that we can make our courses better for both you and other students in the future. Now let's see why one may want to use and learn about pfSense. The first benefit is that pfSense is a feature-rich, robust, and very flexible software. Besides the essential firewall features, it has tons of additional features for network routing, remote connectivity, diagnostics, and reporting, along with many more. What's more, it is an extensible platform. You do not have to settle for the functionality provided out of the box with pfSense. You're free to write your own plugins and add-ons. Many members of the community have done just that. You will go over some of these key extensions later in the course. With all the enterprise-grade features and security pfSense provides, it is incredible that it is a free and open source product. This is possibly its biggest benefit. You can download it from the pfSense website and install it yourself. For large implementations and complex configurations, you do have the option to purchase licensed support from professionals, but that is completely optional. In this course, we will give you all the information you need to work with this amazing piece of software. pfSense is very versatile and flexible. If you are a professional working out of a home-based office, you can use pfSense to protect your network. But if you are a large company running a global infrastructure, you can still use pfSense to protect various parts of your work. pfSense can run on a 10-year-old PC with limited resources, And it can also run on large multi-core servers. And that makes it quite scalable. You can easily expand the resources on your pfSense infrastructure in the event that your network needs an increase. And due to these benefits and many other features which pfSense brings to the table, individuals, network administrators, security enthusiasts, and companies across the world are embracing pfSense. These are just some of the most recognizable names who have adopted pfSense as core part of their network infrastructure. Needless to say, with organizations like Google, US Department of Homeland Security, Shopify, and NASA, when these organizations are putting their faith in pfSense, this free open source firewall solution is here to stay. Before we get going, let's talk about some housekeeping items. To download all the resources used in this course, please navigate to http://go.tetranoodle.com/pfSense. Here you will find the slides and other supplemental material for this course. So if you haven't done that already, please navigate to the URL listed above and download all the resources to your local machine. Once you've downloaded the slides for this course, you can review them from your local system even when you're offline. As you have already seen in the course overview, this course aims to provide you with an in-depth knowledge of a very widely used technology, pfSense. We have tried to provide you with some real-world scenarios and use cases which you will be able to leverage immediately in your own projects. The introductory modules will help you to understand what pfSense is, its features, and the key services it provides, and how you can install it. This education will enable you to do everything from setting up firewalls to load balancing and failover settings to integrating with other software like OpenVPN and Squid proxy server. So I will see you in the next module where we will introduce you to pfSense, its features and services. Hello everyone, welcome to this module on Introduction to pfSense. In this module, you will be introduced to the star of the course, pfSense. You will gain an understanding of what pfSense is, its key features and advantages. You will also view demonstrations on the installation of pfSense on a virtual platform on VMware, as well as some other configurations. Let's get started. Here are some of the key learning objectives of this module. First, you will learn all about what pfSense is, its key features, advantages, and why it's such a great tool. Next, you'll go through a series of demonstrations that will give you a practical insight into installing pfSense on your network infrastructure. Let's get going. Let's start by answering the question, what is pfSense? pfSense is a free, customized distribution of FreeBSD. FreeBSD itself is an operating system for a variety of platforms which focuses on features, speed, and stability. It's derived from BSD, the version of Unix developed at the University of California, Berkeley. It is developed and maintained by a large community. You can use pfSense to turn a computer into a full-featured router and firewall. This software was first developed in 2004 as an offshoot of the popular Monowall project. The main difference between pfSense and Monowall is that pfSense is designed for personal computers and servers instead of embedded devices. This allows pfSense to offer more flexibility and features. pfSense is a very flexible and powerful tool that you can easily adapt to numerous applications, from a home router to a firewall for a large corporate network. pfSense is easy to install and maintain. It has a very useful web-based user interface. pfSense also has many features that are usually only found in expensive commercial routers. You can use 3 types of install media to install pfSense. Optical disk image, that could be ISO image or a CD or DVD disk. This is an easy and familiar choice. Use this option if the target hardware has an optical drive. This is especially useful if the BIOS will not boot from USB. Memstick. This option is similar to the CD-DVD but runs the installation from a USB thumb drive. It's often faster than a CD or DVD. This is very useful with new devices as many of them don't have integrated optical drives, making this the current best recommendation. Serial memstick. This option is similar to the memstick image but runs using the serial console rather than VGA for newer embedded systems. pfSense is a very impressive software. Here are some of its key features. pfSense is very robust and it supports a number of great features. This allows you to have a single device that performs all the functions you need at the edge of your network. The downside of this is that all your functions work from a single machine, so it's a single point of failure. To offset this, pfSense also supports high availability, which means that you can group several devices together. One of the most significant benefits is that pfSense is free. You can simply download the software from the website. Although virtualization is supported, you will of course need to spend on the hardware to install the software on. However, all things considered, it is more cost-effective than other solutions. pfSense can be installed on any hardware, which makes it highly flexible and very scalable. pfSense is also highly extensible. It has an energetic and dedicated community behind it. They have built and contributed tons of useful add-ons to the pfSense platform. Most of these add-ons are also completely free. Let's take a look at some use cases where pfSense can prove to be instrumental. pfSense can act as a LAN or WAN router. LAN, as you know, is basically a group of computers and associated devices that share a common communications line or wireless link to a server. A LAN usually consists of devices connected within a closed area like an office or commercial establishment. A WAN is a geographically distributed private telecommunications network that interconnects multiple LANs. For example, in an organization, a WAN may connect multiple branch offices. A router is used to connect a LAN to a WAN. Wireless hotspot or captive portal. pfSense can work as a wireless hotspot. The pfSense appliance has significantly more functionality and configurability than a typical SOHO security appliance. It is also slightly more involved to set up. pfSense offers some great features such as being able to host a Wi-Fi network for guests outside of the main firewall, even using a different public IP to NAT behind. VPN router. You can also configure pfSense as a VPN router. A VPN is used to add security and privacy to private and public networks, like Wi-Fi hotspots and the internet. VPNs are most often used by corporations to protect sensitive data. Firewall. You can configure pfSense as firewall to put rules and other security settings over the private network. A firewall is a network security system that uses rules to control incoming and outgoing network traffic. It acts as a barrier between a trusted and untrusted network. A firewall controls access to the resources of a network through a positive control model. This means that the only traffic allowed onto the network is defined in the firewall policy. All other traffic is denied. DHCP or DNS server. pfSense can act as a DNS server or DHCP server. DHCP is a communications protocol that network administrators use to centrally manage and automate the network configuration of devices attaching to an IP network. It removes the need to manually configure IP addresses and automatically assigns an IP address to a device, even when moving to different locations. DHCP is supported for both IPv4 and IPv6, that is, Internet Protocol version. With the use of DHCP and domain name resolution all on the firewall, it makes life easier for configuring the network traffic precisely the way you need it. Multi-WAN router support for failover or load balancer. This support for multiple WAN connections enables pfSense to load balance or failover traffic from a LAN to multiple internet connections. With load balancing, traffic from the LAN is shared out on a connection-based, round-robin basis across the available WANs. With failover, traffic will go out to the highest priority WAN until it goes down, then the next is used. pfSense monitors each WAN connection using either the gateway IP or an alternate monitor IP address, and if the monitor fails, it will remove that WAN from use. This also reduces latency to users. Load balancing can be implemented with hardware, software, or a combination of both. Port forwarding / NAT or network address translation. You can also use pfSense to forward ports or network addresses translation. Network address translation, NAT, is the process where a network device, usually a firewall, assigns a public address to a computer or group of computers inside a private network. The main use of NAT is to limit the number of public IP addresses an organization or company must use for both economy and security purposes. NAT helps improve security and decrease the number of IP addresses an organization needs. NAT gateways sit between the two networks, the inside network and the outside network. Systems on the inside network are typically assigned IP addresses that cannot be routed to external networks. Okay, now let's discuss the pfSense features through a use case diagram. This diagram will give you an idea of how pfSense plays a vital role in a network. The router ISP modem connects pfSense to the internet. The switch connects pfSense to various desktops. In this scenario, pfSense acts as a DHCP server, firewall, a NAT device. It can play these roles distinctly or all at the same time simultaneously. Let's explore some other standard features of pfSense. DHCP Relay Agent feature serves the DHCP service for all clients. The firewall feature filters requests and responses by source and destination IPs, source and destination ports. It also limits simultaneous connections on per rules basis. NAT port forwards includes range and use of multiple public IPs, one-to-one NAT for individual IP or multiple subnets. The multi-WAN functionality enables the use of multiple internet connections with load balancing and failover and usage distribution. With this, you can achieve redundancy across multiple ISP connections. And not only that, you can distribute the traffic from your internal network to the internet to numerous links in a load-balanced fashion. As a VPN server, pfSense offers two options for VPN connectivity. IPsec allows connectivity with any device supporting standard IPsec. This is most commonly used for site-to-site connectivity to other pfSense installations and almost all other firewall solutions, Cisco, Juniper, etc. It can also be used for mobile client connectivity. The second option is OpenVPN. OpenVPN is a flexible, powerful SSL VPN solution supporting a wide range of client operating systems. Let's assume the computers are in different sites. You can use IPsec VPN to connect them both together. Now that you're familiar with pfSense, let's go ahead with installation and configuration of pfSense. But before we start with that, let's review the minimum hardware requirements for installing and running pfSense. At the time of recording this course, the latest version of pfSense is 2.x. pfSense is an open source software and occasionally releases new versions or patches. So to review the latest requirements, you should always refer to the latest documentation. So let's review it now. Navigate to the pfSense site requirements page at pfSense.org/hardware. Okay, here we are. This page lists some ready-made appliances which are tried and tested by the pfSense community. If you want to avoid the hassle of building your server and trying out all the components, then it is recommended you purchase one of these appliances. But of course, if you are like a tinkerer or a geek, then you can opt for this option to build your server. Let's review the hardware requirements for building your own server. As you can see, the minimum requirements as of the latest version are very modest. pfSense can run on a PC with 500 MHz CPU and 256 MB of RAM. Do you know of any sophisticated software which is capable of running on these low specs? Anyway, the recommended requirements are a bit higher than these. But still, 1 GHz CPU and 1 GB of RAM is still very modest by modern standards. Here are some additional details for specific components of the system. You can check the compatibility of your network interface cards here as well. This is very important because pfSense is a firewall and its primary function is securing your network. Besides that, there is also a link to the compatibility list for FreeBSD. As mentioned earlier, pfSense is based on FreeBSD, so it'll make sense to check the compatibility of your hardware with FreeBSD compatibility list as well. Now that you know all about pfSense and its features, let's install pfSense on a virtual machine. First and foremost, you need to download the installer files for pfSense. To download pfSense, navigate to pfSense.org/download. pfSense supports multiple platforms and flavors. It also has various editions and versions available. For best results, always use the stable version. And of course, unless you intend to purchase the supported version, opt for the free community edition. That is exactly what we are going to do here as well. From the In the File Type dropdown, select Install. This will ensure that you get files for fresh installation. The other option is to upgrade an existing installation of pfSense. The architecture specifies the target CPU architecture you intend to use. Select the option depending on your computer. If your system has a 64-bit capable Intel or AMD CPU, use the 64-bit version. 32-bit should only be used with 32-bit CPUs. For this demo, we will pick AMD 64-bit. pfSense also supports multiple types of installer options. You can download the installer as a USB memstick, ISO CD image, and embedded nano BSD image. The USB memory stick image is meant to be written to the hard disk of your target system. Installing pfSense on the hard drive is the preferred method of running pfSense software. In this case, the entire hard drive is overwritten. And please note, dual booting with another OS is not supported. The CD image ISO installer is used to create a CD or DVD version used to install on virtual machines or systems with a CD or DVD drive. The embedded version of pfSense is meant to be written to system hard disk before use and is specifically tailored for use with any hardware using flash memory, mostly compact flash, rather than the system hard drive. As you may be aware, flash memory can only handle a limited number of writes, so the embedded version runs read-only from flash, with read-write file systems as RAM disks. The Nano BSD platform has 2 OS slices and a config slice. One OS slice is used to boot from, the other is used for upgrades, and the config slice is where the configuration resides. There are 2 variations of the Nano BSD platform, the default version, which uses a serial console, and another that supports using a VGA console. Each of those variations also comes sized for different sizes of storage media. For this demo, in the platform drop-down list, select ISO installer. In the mirror drop-down, select the nearest location to you, and then click the download button. Mirror sites are useful when the original site generates too much traffic for a single server to support. Mirror sites also increase the speed with which files or websites can be accessed. Users can download files more quickly from a server that is geographically closer to them. In this case, we are going to select New York City. After selecting these options, let's click on the download button to get the required installer files. After the download is complete, let's go to the download folder and locate the pfSense installer file. Here it is. As you can see, this installer file is a zipped compressed format. You can unarchive this file using any usual compression utility like WinZip or WinRAR on Windows and other similar programs on other platforms. Okay, there we go. Now the ISO file has been extracted. You can either burn this ISO to a CD, which will be a bootable CD, and you can use that bootable CD to install the software on your PC. That is, if you are using a physical hardware device. Or you can use the ISO file to create a virtual machine. By the way, you can also run pfSense in live CD mode, where you can just run the pfSense software from the CD without installing anything on your system hard drive. The benefit here is that you can test drive pfSense without changing any configuration on your system. But the drawback is that you will lose all your configuration once your system restarts. So for now, in this demo, we will stick with permanent installation of pfSense on a virtual machine. Let's go ahead and launch a new virtual machine now for pfSense. In this demo, we will use VMware for hosting the virtual machine, but you are free to use any other virtualization platform like VirtualBox, Hyper-V, and so on. Now, we have launched VMware Workstation, so let's launch a new virtual machine here. To create a virtual machine, click File and click New Virtual Machine. A new virtual machine wizard launches, which will walk you through the process of creating and launching a new virtual machine. Let's go through the steps now. Here you can use a typical configuration or more advanced configuration with more options. Let's keep things simple and stick with the typical option. Click Next to begin the wizard. On this screen, you get a few options to install the operating system. You can load the operating system from a CD or a disk image. The default option though is just to keep moving forward with the virtual machine creation and install the operating system later. Let's accept the default value and click Next. Now, even though we selected install the operating system later, you do need to inform VMware what kind of operating system you intend to install eventually. A new virtual machine is like a physical computer with a blank hard disk. Before you can use it, you need to partition and format the virtual disk and install an operating system. So here, VMware is asking you for the intended operating system so that it can prepare the virtual machine accordingly. Since pfSense is based on FreeBSD, let's pick a compatible system. Select the Other Radio button, and for version, select FreeBSD 64-bit as you are going to install a 64-bit pfSense. Click Next. In the next step, you are given an opportunity to name your virtual machine and set the location of the virtual hard disk. Accept the default name, and then you can select the file location where you want to install the software. Click Next. In this next step, you need to allocate storage to your virtual machine. Make sure you select the option to store the virtual disk in a single file. Increase the maximum disk size to 30 gigabytes. Obviously, please do make sure you have enough disk space on your host system to accommodate this allocation. And now click Next. Here you can review all the settings you specified for this virtual machine. And once you're satisfied, click Finish. The virtual machine has been created. The VM is now created, but you still have some networking configuration to do. pfSense is all about networking and security, and so far you have not allocated any network interface cards to this virtual machine. So let's go ahead and proceed with the network configuration. After that, you will finish the installation for pfSense. Typically, pfSense isolates the network traffic for internal and external networks by using different network interface cards. Consider a scenario where you have one network device which is connected directly to the internet, and the second network device is connected to the internal network. That is precisely how most pfSense installations are configured. So now let's replicate that scenario here. Here's the virtual machine dashboard, which was created in the previous demo. Click Edit Virtual Machine Settings. This new dialog box for virtual machine settings pops up. Here you can review and edit any settings for the virtual machine. Let's pay attention to the network adapter. Here you can see there is only one network adapter which is directly connected to the internet. So this could be the WAN network adapter. Now let's add an internal network adapter. Click the Add button. In the Hardware Type dialog, select Network Adapter. Click Next and click Finish. Okay, the second adapter was added to the virtual machine. Let's tweak the settings for this adapter. You want this adapter to be an internal network adapter which does not talk to the internet at all. Select the second adapter and in the LAN segment dropdown, select LAN segment. Within the context of VMware, a LAN segment is a private network that is shared by other virtual machines. A LAN segment can be useful for multi-tier testing, network performance analysis, and situations where virtual machine isolation is important. Okay, after taking care of the internal network adapter, let's also mount the ISO image for pfSense software. Select CD/DVD and click the Use ISO Image File radio button to mount the ISO image to the CD-ROM. Browse for the location where you saved the pfSense ISO file. Here it is in the Downloads folder. Select the ISO file and click the Open button. Click OK. Now that the virtual machine has been configured properly, all that is left to do is to start the machine. You can now begin installing pfSense. Click the Power on this virtual machine link. Now, VMware will launch this virtual machine, and since you have already mounted the bootable CD ISO image, it will boot into pfSense installer. Here it is. This is the home screen of pfSense installer. You are given a few choices on how you want to install pfSense. The first and default option is boot multi-user. This will continue the FreeBSD boot process. So let's press enter to boot into the FreeBSD installer. The kernel will start to load and display boot output. After a minute, a text prompt will appear to install or enter recovery mode. Press I to launch the installer. If no selection is made within 10 seconds, it will continue to the installer automatically. Press I to launch installation when prompted to do so. The installer has now started, and it is giving us the opportunity to change display and other system settings. Let's accept all the default settings. Now select Accept these settings and press Enter. Then it offers the choice of a quick or easy install, custom install, and several other options. Select Quick Easy Install and press Enter. This easy install will take care of a lot of things like disk partitions, etc. Select OK and the installer will begin. pfSense will be installed on the first available disk in the system. It will take a few minutes to copy all of the files to the target disk, so let's allow it some time to finish. When the files have finished being copied, the installer will prompt to select either the embedded kernel or standard kernel. Select standard kernel. Basically, this setting controls whether you get a VGA terminal or serial-based console. If this were an embedded device with no video card, then we would have picked the embedded kernel option. The installation continues. Okay, the installation is almost finished, and pfSense now needs to reboot. So press Enter to reboot. While rebooting, make sure you unmount the CD so that the virtual machine boots from its hard drive and not from the CD-ROM again. To do that, right-click the CD icon in the tray below, go to Settings, and change the selection from Use ISO Image File to Use Physical Drive in Connections and click OK. You can ignore any warning dialogues which may pop up. Click OK and let's get back to the virtual machine. The machine has rebooted and this is the boot screen for pfSense. Let's press F1 to continue booting pfSense. Note that this time it is booting from pfSense, which has been installed on the hard drive of this system. Okay, great. Now, the installation part of this process is complete. Here you can see that one of the IP addresses and networking interfaces has been assigned to WAN network connection. This is the EM0 network interface. EM1 has been assigned to the internal LAN network. WAN network interface has been assigned a dynamic IP address. This is typical for general purpose-based internet connections like cable, ADSL, or fiber optic ISP connections. You may also be allocated a fixed IP from your ISP. These settings can easily be changed within pfSense admin console or right here on the admin console. If you want to change the IP address, you can change it by selecting the second option, Set Interface's IP address, to whatever you need to change it to. We will visit these shortly. The DHCP IP address assigned to the WAN connection is 192.168.67.158/24, while the LAN or EM1 has taken the network address 192.168.67.158/24 1.1.1/24. The LAN interface will become the internet gateway for all the devices within the internal LAN network. Let's recap some of the key points covered in this module. You learned all about pfSense, its key features and benefits. You also learned to install pfSense. Thank you, and I will see you in the next lecture. Hello everyone, welcome to this module on key features of pfSense. In this module, you will learn all about the different configurations available in pfSense and how you can use them to perform different tasks. So what are we waiting for? Let's get started. Here are some of the key learning objectives of this module. You will learn about the features and uses of the different configurations available in pfSense. So let's get going. First, let's answer the question, what is a firewall? A firewall is a hardware or software-based network security system that uses rules to control incoming and outgoing network traffic. It basically acts as a barrier between a trusted network and an untrusted network. A firewall controls access to the resources of a network through a positive control model. What this means is that only the traffic defined in the firewall policy is allowed onto the network and all other traffic is denied. It filters traffic by source and destination IP, protocols, source and destination port for both TCP and UDP traffic. It also limits simultaneous connection on a for-rule basis. Now, let's take a look at a diagram and see how pfSense can act as a firewall. Consider that there is an external cloud network, which represents the internet. Next, you have an ISP connection device like a cable modem, an ADSL modem, or something similar that connects your internal network and pfSense system to the internet. There are two network ports, both leading to two switches. Let's say one is a WAN port and the other is a LAN port. Each of these has numerous endpoints or devices connected to that segment of the LAN, which could be laptops or desktops. Whenever any traffic tries to pass to WAN, it will go through pfSense and then be filtered to the correct route here. Now let's add another layer of complexity. Say there is an additional LAN segment added, which could be attached to a third network interface within the pfSense server. This will be the second LAN interface. Say this new LAN segment hosts some other devices or servers which need to be isolated from the first LAN segment. This is a typical case when you need to host external servers in a different LAN segment which may behave like a DMZ. In the context of computer security and firewalling, a DMZ or demilitarized zone is a physical or logical subnetwork that contains and exposes an organization's external facing services to an untrusted network, usually a larger network such as the internet. The purpose of a DMZ is to add an additional layer of security to an organization's local area network or LAN. An external network node can access only what is exposed in the DMZ, while the rest of the organization's network is firewalled. The DMZ functions as a small, isolated network positioned between the internet and the private network. The term is derived from the term, demilitarized zone, an area between nation states in which military operation is not permitted. In this type of setup, you will set the pfSense firewall rules to isolate the LAN and DMZ networks and not any traffic to overlap with each other. Assume that switch 3 is the DMZ and the switch 1 is the internal LAN zone, and all the traffic is being passed through the pfSense server. Let's understand what load balancing and failover are and how they tie in with pfSense. Load balancing is a function used to divide the amount of work that a computer or a network has to do to accomplish a given task. In case of pfSense, you can implement multiple ISP WAN connections, and you can load balance your traffic between these connections. This means that when a device on the internal network makes a request to an external resource, on a per connection basis, pfSense can route the request over each WAN in a round-robin manner. If any gateway on the same tier goes down, it is removed from use and the other gateways on the tier continue to operate normally. Within the context of pfSense, a gateway is a system through which pfSense can reach the internet or another network. Failover is basically the ability of a machine or a computer system to transfer operation from a failed component to an alternative backup component without interrupting operations or process flow. When two gateways are on different tiers, the lower tier gateway is preferred. If a lower tier gateway goes down, it is removed from use and the next highest tier gateway is used. Let's understand these scenarios in more detail from the next use case diagram. This diagram represents a typical pfSense setup to explain failover and load balancing. Let's first look at all of the components involved here. This first cloud represents the internet connection or ISP1. There's also another cloud that serves as a second internet connection or ISP2. So these are basically two different ISPs and each of them connects to two routers, router 1 and router 2. Next, you can see that both routers are connected to the pfSense firewall. This leads to a switch, which then leads to the different endpoints or hosts. So in a nutshell, this diagram has two WAN ports connecting both ISP1 and ISP2 modems or routers to pfSense. It also has a single LAN port connecting to a switch and thereby connecting to the internal LAN network to the pfSense server. First, let's discuss the failover scenario. Let's say you start off routing all the traffic to ISP1. Everything is working perfectly until one fine and dandy day, ISP1 experiences some technical hurdles and it goes down. If you did not have pfSense monitoring ISP1, you would have a few choices to deal with this situation. You could either manually switch over to ISP2 if you have one, or wait for ISP1 to fix their technical problems. Obviously, both of them are less than desirable solutions. This is where pfSense's multi-WAN support comes in. If you configure pfSense to work with multiple WAN connections and implement failover and/or load balancing, then the failover in these extreme cases is transparent to the internal LAN users. In this case, as soon as pfSense detects that ISP1 is down, the traffic will be automatically redirected to ISP2. In this scenario, we can say that a proper failover has been configured. If ISP2 is only used for failover, then pfSense will wait until ISP1 is back up and running. Whenever things return back to normal, pfSense will start routing the traffic through ISP1 again. So this may be considered an active-passive failover. The second scenario is about load balancing across multiple connections, even under non-exceptional cases. Let's say you have two ISP connections, but they're not the same in terms of their bandwidth offering, quality, and consistency of connectivity. ISP1 is a premium provider which offers a bandwidth of 14 megabits per second and a more robust connection, while the ISP2 has a bandwidth of 5 megabits per second. Now, instead of wasting the bandwidth provided by the second ISP, you could configure pfSense to load balance the traffic across both connections and utilize both ISPs to their maximum advantage. Once again, pfSense is extremely flexible about how you implement this load balancing. You could choose to combine the bandwidth from both connections and use both of these ISPs simultaneously, and the load will be distributed among both ISPs. You could also route the traffic across these two ISPs based on certain criteria. For instance, you could configure pfSense to route all HTTP traffic via ISP1, whereas all FTP traffic could be routed to ISP2. A more usual case is that voice and video communication traffic is generally routed via a more robust and bigger ISP, whereas regular email and web traffic is routed via the cheaper alternative ISP. An added advantage of load balancing is that the failover works without any additional configuration. If ISP1 is down, all the traffic will be forwarded to ISP2 and vice versa, so that the entire network does not experience a downtime. This may be considered an active load balancing. Now let's look at the load balancing scenario. In this scenario, consider that ISP1 has a bandwidth of 14 megabits per second, while ISP2 has a bandwidth of 5 megabits per second. Now, if the internet network has a usage of 2 Mbps, it will use both of these ISPs simultaneously, and the load will be distributed among both ISPs based on certain criteria. This scenario demonstrates the conditions required for pfSense to work as a load balancer. And it also shows that it has been configured properly. If ISP1 is down, all the traffic will be forwarded to ISP2 and vice versa, so that the entire network does not experience downtime. Let's answer the very important question, what is a VPN? A VPN, or Virtual Private Network, is a way of connecting a computer to a remote network in a secure manner. A VPN is a virtual private network that allows you to connect directly to your home or office private network over the internet. Let's say you are in a remote location and want to access the services hosted on your private network. You can use VPN to do this. VPNs are used because private networks with IP address segments such as 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16 are not routed on the public internet, as these are reserved for private networks only. If you have a router running in your home or office, most likely its internal LAN IP address belongs to one of these private LAN segments, and it is not reachable directly from the internet. A VPN gives you the ability to extend this private network by creating a secure tunnel between the remote client in an untrusted network and the server in your private network. This means that once the session is up and running, the remote client can access all the resources located within your private home network. There are many types of VPN protocols and technologies available on the market today. Some of them are proprietary and need expensive hardware components to be implemented. Some of them are open source and rely on software packages to implement the required functionality. pfSense only supports the software solutions-based L2TP, PPTP, IPsec, and OpenVPN protocols. Why are we specifically talking about OpenVPN? Let's find out. Now let's get familiar with OpenVPN. What is OpenVPN? OpenVPN is an open source software framework which implements VPN techniques or virtual private network techniques for creating secure point-to-point or site-to-site connections or tunnels in a routed or bridged configuration and remote access facilities. It uses a custom security protocol that utilizes standard SSL/TLS for key exchange. OpenVPN is very powerful and flexible. Since it is based on standard protocols of SSL/TLS, OpenVPN is capable of traversing network address translators, NATs, as well as firewalls. It was written by James Yonan and is published under the GNU General Public License, or GPL. Since its release, OpenVPN has become a wildly popular platform, particularly for smaller networks. OpenVPN has a strong community of developers supporting it, and it is very well maintained by the community. This works as an assurance that if there's a vulnerability found, it will get patched quickly. OpenVPN works great on high latency connections. It is also capable of compression in case you have limited bandwidth on the client or server side. OpenVPN is a flexible technology. It supports LDAP, Radius, and local user database, which makes it flexible in integrating with different types of environments. If you have a central user management system like LDAP or Active Directory, you could integrate OpenVPN with that system. The advantage here is that the network users do not need to remember multiple sets of credentials. Or you can create a local database of remote users in your OpenVPN server as well. Users can then use these OpenVPN credentials to connect to a remote location. Encryption in OpenVPN is built upon a strong foundation of OpenSSL, which is an open source implementation of the SSL/TLS protocols. These protocols allow us to use these industry standard and strong cryptographic algorithms which are compatible with most systems out there. These encryption mechanisms can be hardware accelerated for better performance. OpenVPN is also cross-platform. It supports Windows, Mac, Linux, and even mobile platforms like iOS and Android. Now let's see what makes OpenVPN different from other VPN solutions. One of OpenVPN's key strengths is that it's highly stable, scalable, and easy to install. Another advantage is that it provides support for dynamic IP addresses and NAT. OpenVPN is an extensible VPN framework. This eases site-specific customization, such as providing the capability to distribute a customized installation package to clients. It also offers a simple management interface, using which you can remotely control or centrally manage an OpenVPN daemon. You can also use the interface to develop a GUI or web-based front-end application for OpenVPN. This makes it easy to use even for non-technical users. On the Windows platform, OpenVPN can read certificates and private keys from smart cards which support the Windows Crypto API. OpenVPN's industrial strength security model protects your network against both passive and active attacks. The security model uses SSL/TLS for session authentication and the IPsec ESP protocol for secure tunnel transport over UDP. These are all industry standard protocols which are compatible with a plethora of other products out there. Let's look at a practical implementation of OpenVPN with pfSense. The internet is represented by the cloud graphic. The ISP modem or router connects the pfSense server to the internet. On the internal network side, pfSense is connected to an internal LAN switch, which then connects to numerous servers or hosts. Now consider a road warrior employee who is traveling, like a geeky Mad Max. At a remote location, he or she may be connected to the internet via public Wi-Fi hotspot or some other public connection which is considered inherently insecure. Now consider a scenario where the remote employee wants to access some network resources on the internal LAN network behind the pfSense firewall. Obviously, direct access to internal LAN resources from an unsecure public network is never allowed for security reasons. But the remote employee can establish a secure tunnel via OpenVPN with the pfSense server. And now the remote employee can send and receive network packets through this secure tunnel. These secure VPN tunnels are built on public unsecured networks. Since each network packet is encrypted on both ends of the tunnel, the network requests and responses are protected from prying eyes. This means that when a VPN session is established, the remote employee will be able to access all the resources located in the private office network over the internet. Now let's go through the configuration steps you need to take for implementing remote connectivity using OpenVPN and pfSense. First, you need to install the OpenVPN package. Then, you need to generate SSL certificates which will be used for encryption of the network traffic. Next, you will integrate OpenVPN installation with an LDAP server for user authentication. Then, you will create the OpenVPN tunnel and configure it within pfSense. And finally, you will export the OpenVPN profile and test the OpenVPN client connection. Let's recap some of the key points covered in this module. You learned all about the different configurations available in pfSense and how you can use them to perform different tasks. This also wraps up this crash course on network security with pfSense. In this course, you have got an overview of the pfSense firewall, its inner workings, and how you can use it to manage your network security and access. You started off with an introduction to pfSense where you gained an understanding of what pfSense is, its key features and advantages. You also viewed demonstrations on the installation of pfSense. Next, you learned about the different configurations available in pfSense and how you can use them to perform different tasks. We hope you find this information useful in your networking and security related projects. We also hope you had as much fun learning about managing network security with pfSense as we had putting together this course for you. Let's stay in touch. You can connect with us directly via social channels like LinkedIn or Twitter, or you can email us directly as well. We'll be glad to help you in any way we can. Please do not forget to leave a review for this course. It will really help us and other learners. And last but not least, please do check out other top-rated courses that we are offering. There are many special offers available for you in the last bonus lecture of this course. Please consider it as a token of appreciation for our current students. There's so much more you can learn about pfSense. How do you configure pfSense? How do you actually implement all of the different features of pfSense? How does pfSense integrate with the different tools and software? If you want to learn all this and gain a deeper insight into the inner workings of pfSense, then join us for the Managing Network Security with pfSense course. It covers detailed demonstrations, tips, in-depth features, and concepts that will help you take full advantage of all that is offered by pfSense. Hello there, and congratulations on finishing the course and making it to our very special bonus lecture. You get an e-gold star. Thank you so much for enrolling in our course and making it all the way to the end here. We want to share with you information about some of the other educational resources that we have built. Since you've taken this course, we would love to see you in many of our other courses, and we want to give you the absolute best value and create an awesome win-win-win situation. You get smarter, our courses get better, we sell more courses. It's a win-win-win. Here are all the courses that we have published so far, and more are being worked on as we speak. Well, I speak and you listen. We also have a website, www.tetratutorials.com, where we publish these courses. In the coming months, you can expect this list of courses to grow and multiply in numbers. One thing that we can guarantee is that we will strive to bring you the most useful and relevant information in all of these courses. Taking one of these courses will improve your life, be it a better job or getting a promotion or gaining a much needed skill set to launch your next idea. As lifelong learners ourselves, we know that as a student, if you enjoyed working with a group of instructors and really benefited from taking one of their courses, chances are that you will really enjoy taking another one of their courses. Think of it as watching another episode of your favorite web series. And since you've already done that with one of our courses, we would like to share more information and knowledge with you. Like I said, we're geeks and we love sharing knowledge. We want you to really feel good about enrolling in another one of our courses, and to help you along and show you our appreciation for you being you, we are extending this special discount to you. You can use this coupon on your screen for any of our courses and get an exclusive deep discount. Here on our website, you can find all the relevant links to our social media channels, as YouTube, Twitter, LinkedIn, and so on. And we also have a blog here where we share relevant information. So please check that out as well. While you're here, please sign up for our newsletter as well. We regularly send updates about our courses, industry news, and sometimes special discount coupons in the newsletters. So it's a great way to stay in touch with us. One more thing. We would really appreciate it if you could provide us with honest feedback and leave a review for this course. Good or bad, we will love to hear from our current students and continue to improve our content based on the feedback. This not only helps us, but also all the other students like you who are looking for similar content. So by leaving feedback, you are making the world a better place. We are really looking forward to hearing from you and to continue to serve you. Thanks a lot for taking this course and watching this video.